Hello everyone, welcome to my presentation, deployment of Postgres in Kubernetes with high availability. Let me first introduce myself and company that I'm working. My name is Armin Esseren, I'm database engineer. I work with Postgres in HA since 8.3 version when there was trigger-based replications, and I then moved, of course, to streaming replication and all together. And recently, I've been working with Postgres running in Kubernetes in production environment. I've been working in Cybertech since 2017, and Cybertech, we offer. Let me just spread a little few words about Cybertech. We offer database services, data science, and Postgres service. We offer basically everything that is concerning data and a lot of Postgres things, from support, training, consulting, tuning, clustering, name it. We are global, we are international. There we have multiple offices in Europe, in Poland, Switzerland, Estonia, and we are based in Austria, and we are also in Africa and South America, and we are spreading. We have a large number of different clients from various sectors, and this is just a couple of them. You see the Amazon on the top. We are not using their services, but they are our client. Yeah. Now back to the talk. Why Postgres inside of Kubernetes, or why Kubernetes at the first place? So currently we are living in a world where where service-oriented architecture is all around us, and that's where Kubernetes fits in. It seems like Kubernetes is having good future. Everything is kind of, it's hype now, but it seems like it is going to stay. Yeah, it's here to stay. And of course it's free. You can test it, you can test it home, you can test it anyhow, you can install it in production easily, no problem. And all combined, if we want Postgres quickly available for everyone. So of course we know that Postgres installations, classic installations, could be kind of demanding. You need some kind of configuration and managing around it. And if we have large, for example, team of developers that kind of quickly wants one Postgres installation, that's one example of using it. If we want to provide services to our departments, for example, of course there's just one way to deploy it quickly, and that is why I'm talking about it. Now I'm kind of talking a little faster and moving forward. I plan to do a little demo at the end, and we are limited in time, and this is why I will try to kind of skip to the important parts. Now let me just mention what is my plan to talk about here. I will just said a little bit about containers, how they are managed with Kubernetes. I'll just mention storages, as storages are main part of database, as we are storing something somewhere, right? And we need to kind of be sure about storages. And then I will show how to deploy Kubernetes on a simple way. I mean, not show, I'll just mention how it's easiest way to deploy there, and how to deploy it with Kubernetes operators and what they are mean. And then how to do everything automatically, and how that can be done in production environment. I will show and said how failover recovery is done, and if there is a time, I will just show and say how backups could work in that configuration. Now let's move to containers. Containers are kind of they're starting to be more popular and popular. Before, we used to do a lot of things to run some piece of software somewhere just to test it, don't configure it, whatever. Now we are with containers. I'll not go into that what are containers, and we it's just they are main features of containers is they cost us less, they are lightweight, there's basically just one process running, but it is acting like it is in home or nature environment, and that's the core of the thing. We can run something inside of a container that something would act and think as it is in their home environment. It is standalone, and we can run it same way or anywhere we want. I can build, for example, Postgres image on my computer, and then push that image on a registry, and one can download it and use it the same way as I did on my environment, and that's pretty cool. Now, containers inside of Kubernetes. Of course, when we when we are able to run something in container, that's kind of cool thing to do. But then if we want to run it in production environment, if we want to be sure that it's running there in a stable way, we need some kind of ecosystem around it. And there from the beginning, when containers started, it was kind of struggle to get there, but then with the softwares as it Kubernetes, things started to be more simple, and Kubernetes is actually there to manage and to deal with those containers and to help us manage multiple number of containers and running them together and connect them and schedule them and help us everything around it. Of course, when we have some kind of containers that are services, we need to be able to connect to them, we need to be able to move them from one node to another, and we need to have some kind of storage there. Now containers are of course from the beginning meant to be stateless, but now when we have all those architecture around, we are using them also with some kind of storage to store some kind of state or some data, of course. And Kubernetes knows to how to handle that. There is there is storage orchestration that helps us mount some storage on the different nodes where Kubernetes is running. It helps us also with rollouts and rollbacks. It means that deploying things and reverse, moving back to previous state, it's kind of smooth, and if well configured, can be without notice for customer, for example. That's where Kubernetes helps us. And self-healing, of course, what is meant by self-healing? It means that with proper configuration of health states, we could configure some kind of actions for containers or pods to be to keep them in a certain state. And of course, there is also secret and configuration management. So whole package that actually can help us to run Postgres in there. Now, Kubernetes can run, of course, on a bare metal. We can install it on servers and configure it and be happy with it, or we can actually use some providers and use their services, so deploy everything in there, and someone else would take care of storage or exposure to the public world, and everything have its own advantages. I will not go into depth now or discuss about what's better. Everything, everyone have its own requirements, and for someone it's who is not able to use provider services to have this need to have everything at home. Of course, there's bare metal solution. If that is not concerned, of course, then it's provider solution. But always have in mind then providers have some kind of limitation. For example, storage options. One would need to fit into those frames of providers. The point is, anywhere, I mean, it's not important where. Kubernetes, Postgres in this kind of configuration that I'm going to talk about will run the same way, and everything will be smoothly, right? Now, this is simple architecture of Kubernetes. Now, I want to just mention how with the accent of HA. So that means Kubernetes is running on multiple physical servers. So there are nodes, and each of those nodes have, of course, operating system, have Docker, in this case, Docker layer. There is Cubectl, that is service, basically controlling what images are, not what images, it's basically talking with Kubernetes API and executing the orders from Kubernetes API. And on certain nodes, Kubernetes nodes, they are called master. They are brain of Kubernetes, so services that are taking care of how Kubernetes works. Now, with this picture, we see that we can run everything on each physical node basically on the same way if we want to, of course. And that means everything that is run, for example, if we run Postgres on node 1 of Kubernetes and that node 1 dies for any reason, we can just run the very same container on node 2 and everything should act the same. Now, in order to be that way, there is a storage layer below that needs to be accessible from all those nodes. Okay, so our Postgres needs to be able to mount some kind of, I mean, it needs to be able to mount data folder, and the very same container on a next moment needs to be able to mount the same data folder on the node 2. And on Kubernetes we can, of course, organize things like that. And yeah, down below there is image registry. That means that all of those nodes needs to be able to access this image registry in order to create images that we want to run. Now, how do we talk with Kubernetes? Let's imagine there is some Kubernetes installations for provider or whatever, and we now want to tell him, okay, tell that Kubernetes, okay, let's run some Postgres inside. If it is configured that way, that we have storage and there are multiple nodes and whatever, we talk to it, and we just through the interfaces, through the API, with the API or with client library, we are talking with Kubernetes and configuring our services, and in this case that would be Postgres. So Cubectl is just a little command that is run on a workstation. If it is configured to talk with the remote Kubernetes, it will just translate our instruction to Kubernetes API calls, and via command line we can basically do anything we want. Or if we want to implement some kind of logic, some kind of intelligence in our own code, there is client library, so we can include that client library and based on some kind of logic create Kubernetes resources. That means create Postgres that will run on some Kubernetes installation. This is just one simple YAML file that we could apply via Cubectl command, and based on this YAML file, there will be we are telling Kubernetes to create a deployment. That means to make sure that there's always 3 replicas of Nginx running, and we are specifying what image needs to pull in order to do that, and applying this to Kubernetes will basically create 3 some three very same containers of Nginx. That is how simple can be. Now, if I show you how you could run a simple Nginx, now how we could run simple Postgres inside of Kubernetes. The very same way, we would need to specify the image, we would need to specify some more thing, and Postgres would be there. There is a lot of images of Postgres around there, but we each installation of Kubernetes needs some kind of configuration, and if we want to run it like that in production, it would be kind of hard. We would need to specify all those things manually, and we would need to, I don't know how would we in that case manipulate with updates, with changing. For example, we deploy 100 of that kind of Postgres installation. How would we change on all those 100 Postgres installation something? So the previous sample of Nginx installation applied to Postgres installation would be kind of tricky to manage in a production environment. What I'm trying to say, we need some kind of prepared Postgres container to be run in this kind of environment, and that prepared image needs to have everything what we need in order to run Postgres in production environment in Kubernetes. That means it needs to be small, but yet it needs to have all the things we need for Postgres. That means, for example, multiple versions of Postgres, plenty of extensions, all those base extensions, plus some maybe some other extensions, some additional tools for backups or for pooling, and it needs to be configurable via environment variables, because that is how containers are configured. We run it, we have image, we pass some environment variables, and based on those environment variables, we actually create some container in a certain state. And after we have Postgres binaries started and configured, we need to be able to manipulate with multiple Postgres working together. We want them in a cluster, right? We want HA, so we need Patroni for that. Patroni is it's a tool that is helping us with streaming application and with clustering Postgres with automatic failover and all around it. So it's Python daemon that basically is a wraparound PGCTL. It is managing one instance, and then it's keep cluster state in DCS, etcd or console or zookeeper or whatever, and it helps us automate things like cluster deployment, like scaling and configuration management. And it actually, in this case, it is needed to bond multiple Postgres containers together into one cluster. So we need, what I'm trying to say is, we need one image having all of those inside, so we can run Postgres, containerized Postgres inside of Kubernetes environment. And yeah, this is image. How would that look like in Kubernetes environment? So this is, we see these two pods, pod named demo 0 and demo 1. Those are two pods that are running on different nodes, and they are accessing different storages. So yeah, sorry, just and in this case, they are I'll just moving myself so you can better see the screen. So they are accessing persistent 1 and 2, but data between those two are actually replicated, I mean, through the streaming application. Everything what is in a master pod will be replicated to persistent 1. So in case the master dies, the replica will take over. So we have pods that are Spilo image plus Patroni, and there is Kubernetes resources, endpoint secrets, and services. So we can actually access from outside. Now I will show a little bit more in detail as we go. Now, considering that typical life cycle of Postgres looks like this one on the picture, that means we create some kind of cluster, we deploy it, we provision something, so create some predefined things, logic, database object users, whatever. We use it and then we delete it, and then all over again. So we have some kind of logic, some kind of intelligence that is happily typically on as a life cycle of Postgres. So that means there could be one operator, Kubernetes operator, that can actually do that kind of logic and help us in order to get this life cycle of Postgres happen, right? So what is Kubernetes Operator? That is the thing that encapsulates knowledge of human into the service. It's actually one pod, one program running in separate container that is monitoring some custom defined resource of Postgres. In this case, we will create custom resource named Postgres. So we will have, along with other things in Kubernetes, we will have also a Postgres resource. So we will just create multiple Postgreses, and our operator will monitor that resource, and based on that, it will adjust a state. So that logic and that is all available around. So there is a Zalando operator, of course, if there is a Spilo Postgres image, if there is Patroni, the tool for HA, there is a Zalando operator. So that is the Kubernetes operator that manages Postgres installation. So we are able to run Postgres installation automated inside of Kubernetes. We actually define, as I said, custom defined resource Postgres with this operator, and we are creating it just like I showed how we create a deployment for Nginx. We would create one Postgres. This operator will watch that custom defined resource, and based on that it will create Postgres instances and do everything automatically, auto repeat, smart rolling updates, create database objects and everything. This is how that manifest of Postgres looks like. This is the simple version, of course. So in the previous example of YAML file, there was kind deployment. Now it's kind Postgres. We gave it some name. We add some storage size of the volume. Now for this, in order for this to work, your Kubernetes installation needs to support dynamic provisioning of storage, and if that's the case, you just specify the size and you are good to go. You provide here the number of instances, and there is some users and database, and of course at the end version of Postgres. This is already old, but of course current version supports latest version of Postgres. And at the end, this is how the things looks like. Just a second to move myself somewhere. Yeah. So yeah, we actually create an operator that will we create one config map, we create the deployment for operator, and after that we actually create just Postgres custom defined resources, and operator will create a stateful set that will create multiple pods, and those pods will use Kubernetes etcd in order to see if anything breaks up. So in order to see if there is failover needs to happen. And they are created, of course. Operator is managing secrets, so after we create one installation, it will generate the password, and we can access that secret in order to be able to connect to the Postgres. Now, of course, this represents everything that is happening inside of Kubernetes, but I think it will be more clear when I run a demo. So how scaling is happening? Not adding more nodes is pretty easy. We just specify a different number in manifest and apply that configuration, and operator will do everything for us. And the same thing goes for removing them. We just decrease the number and apply it, and that's it. We actually also changed Postgres configuration like that. It is actually a Patroni feature. We change, for example, workmem on a Postgres CDR, apply that to Kubernetes, and from there Patroni will take over and apply it to the cluster. And yeah, as I said, it's all matter of changing Postgres CDR, and operator will pass that to Patroni, and Patroni is taking it from there. Now, how backup is handled here, you might ask. It can be done in multiple ways. There is a configuration for logical backup, so pg dump created on some scheduled cron parameter, or there is a streaming backup happening with the point in time recovery option. So for example, on a scheduled time there will be full backup happening, and then we can provide a S3 like configuration for whole archiving and for possibility to restore our cluster with the point in time recovery option, as I said. And restore is pretty easy, and I'm not saying this for logical, because for logical is not automatical. You will have your dumps on the storage you configured, but for the whole G, we actually create a new cluster with timestamp parameter and few parameters saying operator to take data from backup and to create cluster out of that. Now let me try. I don't have much time, but let me try to do one small demo. So yeah, this is my freshly cloned Zalando operator code. So I just did git clone and Zalando operator, and that is what is happening there. And I've also run Minikube on my local machine, so I have empty Minikube there. Cubectl, after I did Minikube start with Cubectl, I'm communicating with my Minikube. So we see that there is nothing there, and so this is actually Zalando code clone, and inside of that there is manifest. There is manifest folder, and all those are just some simple templates provided by Zalando, and with all those simple templates you can actually create a cluster. Now in order this to work, I would need first to create a config map, and there is a file named config map, so I will apply that to my cluster, to my Minikube. Cubectl, and I specify config map, and it is applied, and then I will create an operator, so just an operator pod that will watch for a Postgres CDRs. So Cubectl apply, and there is Postgres operator YAML file, and operator is created. Now I'll need to check that, and of course, there is now one pod that is Postgres Operator running. Now I'm able to create one simple Postgres CDR. Now there is a file called minimum something, so I'll open it. Minimal Postgres Manifest. Yeah, that's simple manifest. So kind Postgres name, namespace, and there is size of 1 GB of storage, 2 instances, some databases and some users, and version and specified version. So I will create this cluster, minimal Postgres Manifest. I need to say that this is a file, of course. And now I have created Postgres CDR. Now it said that here create failed, I don't know why. But we will see what's happening. Let me just create I did this previously, so I already have it with the same name. I'll just change name. Minimal cluster 2. Let's try now. Okay. Now I see that my acid minimal cluster 2 is creating. And if I check pods, I see already 2 Postgres pods 0 and 1 that are running. If I look at the logs of the first one, I see that is already promoted, and there is Patroni output that it is the leader and it is running. So I have just like that created a Postgres cluster with 2 nodes. And if I log into this one, if I log into the first one, I'm now inside of Spilo container. Now I can see that there is leader and replica, and they are both running on timeline 1, and everything works okay. So I have created with just this file, a Postgres cluster with 2 instances, and they are connected together. Now let's try, for example, to simulate that first one dies. I'll just kill this pod. So I'm deleting this one. It will be, of course, recreated because the operator created stateful set, and it's taking care that number of pods is always as specified. Now let's check the pod. We see that the first one that I've killed is creating again. So container is creating and it's already running. But let's now log into the second one and check the status of Patroni. And now we see that the second one, so the node 1 is leader, and the first one that died and recreated itself is replica, and we are on timeline 2. So timeline changed. So this is how operator automatically creates failover. So it's actually promoting the replica to leader, and the newly created pod is syncing and adding it to a cluster. Everything is automated. This is how things can work. Now I just want to demonstrate quickly. I'm already past my time for example scaling, how scaling is happening. So I will just increase this number to 3, write a file and apply that file, and check the number of pods, and now we see that third member of Postgres cluster is creating. And if I log in there and check the patroni, I see that third node is creating replica. So, and it's already there, so it is just beautiful. That's it. I don't have much time. I hope that this squeezed presentation showed you how we could run Postgres inside of Kubernetes with HA, and of course we can build on that a lot of things, and I just showed these simple principles. Thank you for listening, and let me see if there are any questions. Thank you.